I'm Chris Reedy, the Facilitation Manager for Research Computing. So I'm going to give you a quick tour of the equipment here. So this machine that you see right here is Ocelote. The two things that you'll notice when you look at that is this degree of sameness, homogeneity. So each of the sections all are kind of the same, and they're connected in the same manner. So when you're running jobs and running multiple jobs or very large jobs, it doesn't matter whether you're running on compute nodes here and over there. They all work the same. What you might notice also is this big cluster of cables here. This supports storage. So all of the compute nodes go to our shared storage, which I'll point out later. And there is a second one here. And if some components fail, everything else keeps working. So we're going to walk around to the side and take a look at the other machines we have. So again, that's Ocelote, and then this one's Puma. So you see, not as exciting to look at. What is interesting about Puma is that it's much more dense. So there is actually more than twice the capacity in Puma as on Ocelote, and it actually takes up a little bit less floor space. Then the last machine here is Elgato. Elgato is 7 years old, and we still keep using it because it has an unusual geometry. It's narrower, let's say thinner and wider, and it's the only thing we can actually put in that space that we have available there. So as long as Elgato keeps working as it does, we'll keep it in that place. Another point that I would make about the equipment room in here is we keep it really clean. And the consequence of cleanliness is reliability. We have relatively few failures. So Elgato, even though it's 7 years old, will experience a failure maybe every other month, something like that. And Puma has very few failures now that it's kind of settled in. So here's an example of a compute node. This is out of Elgato. So it's older, but the geometry really hasn't changed inside a compute node. So what you see here is this is either referred to as a socket or a processor, and there are two of them. We have two in each of all of the compute nodes because that's the most price performant option. And within each socket or processor, there are cores. What's confusing is that Slurm will refer to these as CPUs. This one has only 6 cores in here and 6 cores in here. But Puma has 48 cores in here and 48 cores in here. You'll also see DIMMs in the DIMM slots. And in Puma, they're all occupied. Puma has 32 gigabyte DIMMs, and there are 16 of them. So if the math is right, that's 512 gigabytes. In here is a disk. All of our compute nodes have a disk. The new ones are NVMe, so they're faster. And so that's mounted as temp/TMP. So it's very efficient, quick storage for your compute jobs, but it's transient data. When your job ends, the space gets cleared out. But if you...
How big are those SSDs you mentioned?
The ones in Puma, they're 2 terabytes, but take out the operating system and you're left with about 1.3 terabytes of usable space in /temp. What is useful in this configuration to see is what's contained within one node.
Okay.
So I just point out we have fire suppression in the room. And fire suppression is all handled from this tank. It'll discharge. And there's a sign on the door that says can cause death. And really that's about that it sucks the oxygen out of the room. Which is not good for people, but it's good for putting out a fire. This is some of the storage we keep. This storage array here we call rental, and that's where you want to rent storage per terabyte per year. So we'll have it in there. We have plenty of room to expand it. So this is an air handler, basically an air conditioner. So it blows cold air under the floor. All of the power goes over here. It starts with these large steel pipes, and it ends up coming out like these power whips, right power into rack. The other thing that you can see is the water supply. The water, this chilled water comes from across the street and it goes underneath the floors. So, what that means is that all the electricity is overhead and all the power connections and all the water is under the floor. So we keep water and electricity away from each other. This is what Elgato looks like. If I just randomly open one of them, you see all of the compute nodes, they all kind of look like each other more or less, just like all of these nodes do. And so Elgato is connected with Ethernet, which is this, and InfiniBand, which is the black ones. So the black connections connect all the nodes to each other, and these ones connect out to that data. So when they're red, just indicates there is some condition. And all that these mean, in this case, is that the air temperature is getting a little bit warm. So we track all of this remotely. If you're in the room with me, you would notice it's really, really loud coming out of Kuma. The other thing that you would notice is that it's really cold here. And it's capturing all of the heat. So where my hand is now feels quite very warm. And then the last thing I'll show you is our storage arrays, just around the corner here, after the networking rack, where the switches are, Cisco and the like. All of our storage that's not on an internal disk comes back to here. This is the external array. All of these are NVMe, so this is an all-flash array. This is what you get for about $1.4 million. Doesn't look like a lot, but it's about 2 petabytes of storage. And the speed of it makes it really efficient, and it boosts our productivity on the clusters by maybe 20%, because you don't have to wait for I/O to occur. It's just very, very fast.